Okay, so let's continue with the lesson, and now we're just find the. So now what we will do is to continue with the plotting stuff, and at this point, what we are going to learn and see how to do. We have yeah. One. Yeah, so what we are going to see and see how to do these kind of plots. So you will learn and see how to do basic plots using Pandas. So basically we are still going to do Matplotlib figures and graphs and plots, but we are going to do them by using Pandas functionalities. So because the Matplotlib is behind Pandas, so we are basically going to use similar kind of functions and things to modify our figures and so on. So kind of the goal of this part of the lesson is to create this kind of figure where we have these subplots. So we have these 4 different panels where we have winter temperatures, then we have spring temperatures, summer temperatures, and fall temperatures, and they are all separated into different panels. So this is kind of where we are aiming at now. And before we can reach there, we kind of need to do specific stuff about with our data, and now we will learn more about how to deal with date and this kind of time information in Pandas, because Pandas is really good at it. So we will learn a few nice tricks how to do stuff with date. What we are going to use as a data. So there is a link in the Pandas plotting lesson materials here, and basically it is this kind of similar data that we have seen already earlier. So we have hourly observations, so actually every 20 minutes. No, actually now it's hourly data, so it's not like hour sharp, but for some reason they are measured well 150, 250, 350 and so on, but let's not focus on that, so it doesn't matter really. But what you will do is to download this data file from here, so you can do with right click and then save link as, and then I will put this into Dave's root home folder and save it. So in here we have around 16.5 thousand rows of data, so we already have quite plenty observations, and we have hourly data from covering the years 2012 and 13. So we are starting to do stuff with that. Okay, so the first thing that we will see is how to read that data into Pandas in such a way that we kind of directly understand this column, this YR, whatever, and this information as time, so that Pandas understand that okay, the information from this column should be thought to be kind of time information. So let's do that. I will, let's see, do we have spider here somewhere? It's crashed, so let's start it again. So just open up the spider, and what I will do now again is that I will write all my script and all the stuff in the left one here, so that we have it and we can redo it later. I will just save this as well. Lesson 7, pandas plotting. Yeah, and then just let's see, file and save as. Yeah, and I put it as name pandas plotting, like this. Cool. So then we are ready to start. So the first thing what we want to do is to import specific modules that we are going to use during this lesson. So first of all, I will import pandas. Then, as earlier, I will also import the matplotlib. So matplotlib.pyplot as plt. So these are good to have. In addition, we have this specific module that can work with time information called datetime. So I will also import one kind of function from there. So from datetime, import datetime. So this is just a function inside a module that is called the same. You will see later what we will do that. And then as well I will import numpy as np. So with these 4 modules we will start doing the stuff, and I can see that everything works by running the stuff. So now we should have everything available. So I should have my file under this whip folder. I'll just press enter there, so I should have my working directory under that one. We can check the working directory with the pwd, and indeed we are working there. So now I should be able to read my data. So I just called fb equals to, actually I do it here, fb equals to what is it? It's this number, this kind of thing. So I have a data file called this, and I just copy and paste it into my script like that. So now I can use that. Then when reading the data, so let's do so that we read the data with time information and parsing that. So how we can do that is that we say that okay, data equals to, and then we read the data again with the pandas.read CSV. And as always, we specify first the file that we want to read, so it is this fp here. Then we define the separator, how the columns are separated. In our case, well, it's comma separated, so we have the comma here. Then, if you remember, we had this bit strange formatting here. We had these star characters for no data, so we need to again deal with those. So it is done similarly as in exercise some 5 or 4. There's one.
Well, it's not comma separated, it's space separated.
Oh yeah, that's true. That is true. Yeah. So it was space separated. That was a good comment. So how we were able to do that was to use this specific formatting like this. So in this way we can read the data, but this needs to be other way around, so it's backslash, not like that, not like that. So in this way we can read the columns with spaces that might be varying length long. And then as where we started, so the not non-numbers, so not numbers, so the no datas we can specify by saying that all the values with 1 star or 2 stars or 3 and so on. So I just copy and paste this here. Here we have 3, here we have 4, here we have 5, and here we have 6 stars. So in this way we can clean all the data from those star characters and specify them as no data. So this is exactly the same that we did in some of the exercises. But the new thing, what I now want to do, as said, so I want to read this information from this column and parse that as a date information. So there is this specific function or parameter in Pandas read CSV called parse dates, which is really handy. So with this parameter, we can specify that from all the columns that you list inside here, those values should be interpreted as dates or time information. So in here we can basically specify that read the information from this column and use that as information for the time. So I just copy and paste that. So we have this year, month, day, blah 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 in here. So now we should be ready to kind of execute this. And again, I can do it by quickly with F9, pressing F9 character in my keyboard. And now we should have the data. And as always, it's good to see that what do we have here. And okay, it seems that we successfully cleaned the no data, the star characters, and converted them as no data values here. And then what we can see from here is that this column, year, month, day, and whatever, is now kind of the formatting changed a bit. So here it was this kind of basically length of numbers or many long number basically, but because we read that and basically interpreted that as date, Pandas automatically converts it into this kind of nice looking date information that is really easy to kind of understand that okay, this is the 1st of January at midnight and 50 minutes past that. So this is what happened, and we can also see that is that really the case. So when we are looking at the data type, so data.dtypes can be used to check all the data types of different columns, and when we go up here and see the third from above, we can see that okay, these are integer values, but now we have this kind of new data type called datetime. And this is something really useful for doing these kind of data manipulation and operations with dates in Pandas, and we will shortly see what we can do with that. Before continuing, I think we have many columns in our data frame, and we are not interested in those. So let's do the same stuff as as before, and we just select certain columns and maybe convert the Fahrenheit temperatures to Celsius, so that it's easier for us to understand what is going on. I will just copy and paste the stuff from here, because you have already seen many times how to select columns, how to make a conversion of or rename the columns and convert the temperature. So there is no need to go use time on those. So I will just now execute these here. So at this point I only selected those columns. We can check that it happened. Yeah. So now we only have 3 columns in our data frame. Then I just convert the names, and let's see what we have now. So yeah, indeed, now the names changed and they are more intuitive. So we have time, we have temperature, and we have speed. And then finally what I will do is that I convert those Fahrenheit temperatures to Celsius, and we are using the formula that we have seen many times before. And just by doing that, now I should have this kind of data frame with time, temperature, speed, and Celsius temperatures. And here we have the index values, so from 0 to 4, so the first 5 rows. So everything looks good. The first thing what we could do is that, of course, well, now we have the data, so why don't we take a look, how does it look like? And we, on the last part, Dave showed you how to do it with Matplotlib, and now I will show how to do it in Pandas. And it basically works in a similar manner. It's really easy to do. So let's say that plot the Celsius temperatures. So that is what we will do. And in Pandas, you just called the name of your data frame. So we have called data dot, and surprise, surprise, there is a function called plot. So this we can use to plot the data from our data frame. And here we specify with x parameter, so what is the x-axis column, and then we just say that, okay, I want to have the time, so we have the time information, so I want that to be the x-axis column, and then the y-axis is Celsius. So that's it. So now we can see by executing what happens. And indeed, it opened up this kind of figure, and we can see that we have the Celsius temperatures here. We can see from time, so Pandas automatically kind of created quite nice formatting, which is different than what we saw with Matplotlib. So there we have this long number basically, and the values. But here we actually have really nicely, so we have the year here and the month, because we have so long period of time data, and it kind of formats it automatically this way. What we can see from the data itself is that, well, we have these clear patterns. So we have the summertime in here where the temperatures are higher, and the winter where they are lower. So this looks quite kind of intuitive and logical what we have here. So what we could do is that, as we can see, this is quite crowded, and that is because we have a lot of observations that we are actually plotting here. So we have these hourly data points, but as we have 2 years of data, we don't necessarily need to have such an accurate kind of information available. It could be just enough that we actually plot daily temperatures. So let's do this kind of data aggregation once more. previously we learned how to do it using this kind of string manipulation and use the grouping. Now I will show how to do it using the datetime information in Pandas, which makes it ridiculously easy to do. So let's do that. Now, okay, I knew how to do that. Cool. So first thing that we need to do when doing that, I will just comment that out so that won't be plotted again. First thing, what we need to do when doing this kind of time aggregation is that we need to specify, so this is our data. So what we want to do is to make this kind of datetime index. So instead of having this kind of sequential number going here from 0 up to 16,000 or whatever, we want to have actually the time as our index. And when we have the time as our index, we can do all sorts of selections, combining to comparisons between is this date larger than that one, and so on. So it kind of provides us many functionalities when we have the date time as our index in our data frame. So let's see how we can do that. It is easy to do. So first of all, we said give a comment, change the index. So how you can do that is that I just called data equals to data dot, and then we have this function called set underscore index. And inside here, we just specify what column do we want to use as a new index value. And here I specify that, okay, I want to use the time information and set that as our index. And let's see what happens when I run this. Now, here. So what we can see here is that it looks almost the same as before, but actually it is somehow different. So the time was as a column here, but now we have the time. It's kind of, you can see that it's lower here, so it's actually our index at this point. And we can actually check what are our index values by calling data.index. And now we can see that, okay, instead of having those numbers from 0 to 16,000, we have these kind of date time information as our index. And why is that useful? Well, it is useful, for example, for that reason that we can actually do selections of data really easily. So I can, for example, select data from January the 1st, 2013 by doing this. So select data. So I create a new data frame, 1st of January, like this. And in there, I can use just a simple and a similar kind of a list indexing method as we have used before when selecting certain items from Python list or from Pandas data frame. So instead of putting numbers here, now I can actually just insert inside a string this kind of date information. So I want to select data from 1st of January 2013 up to, so actually the same date. So I want to include only one day of data in here. So I will just put the same number, and then I will only get that value from the data frame. And let's see if it works. Yeah, we should have the 1st of Jan And indeed, now when I print the outcomes here, we can see that the date indeed is all the time the January the 1st. We have all hours from that day included in our data frame, and it was quite easy to do just by specifying these kind of strings inside the square brackets. And you can do selections of, for example, specify certain month only. So just remove the day from here and basically, or actually not remove the day, but say that I want the 31st of January, and then you have the whole January data included and so on. But of course, you can also specify more in a more accurate way. So we can, for example, say that, okay, I only want the first 12 hours from that January. So I can basically say that 1st of January, and I add here 12 h like hours, like this, and then what I do here is that, okay, I just continue this a bit and specify that I want to have the values that starts from midnight, so 12 a.m. or p.m., whatever that is, and then I want to have them until noon. And this way, when I execute this, I should have the first 12 hours only in my data. And indeed there is, the data is like that. So we only have now those 12 values from our data frame. So these can be really easy to use and useful thing to know how to do, and especially when thinking about exercise 7. So this week you might want to see and learn how to do this, because you might need to do this kind of thing in the exercise. But then, so that was about selecting data, but what was the main point here when starting to go was to do the aggregation. So in Pandas, using date information to do kind of aggregation, so change this hourly level data into monthly observations or daily observations or whatever kind of interval you want to use. There is this function called resample in Pandas that takes advantage of this datetime index, and that we can use to do this kind of aggregation of data. So it is really kind of easy to do, much easier than what we did before. So when you were using the kind of string manipulation to kind of ungroup and that way do the aggregation. Those are important skills to learn, so that's why I made you to actually do that. So it's important that you can do actually string manipulation. So, but when doing this kind of datetime aggregation, this is quite handy way of doing it. So aggregate data from hourly observations into daily obs. So what I will do is that I will create a new data frame called daily, where I will take the data from the data frame, and then, as said, I can use this resample function and call that. And what that basically takes is the whole data frame with the datetime index, and based on some rule that you specify, it will do aggregation and combine those rows together. And basically what we want to use as a rule. So there is this parameter called rule, and with capital D we can specify that, okay, I want to have daily observations. If I would use capital M, it would be monthly and so on. Age was hour and so on. There is in the materials here we have a link to the documentation where they are all of these different possibilities that how you can aggregate data. So there are actually, you can use, for example, business days. If you are doing some kind of work with industry or with, for example, some stores or whatever that are interested in business day kind of information, so you have really handy way of actually do this kind of manipulation and aggregation based on those straightly in Pandas. But yeah, as said, I want to have those hourly level observations aggregated into daily level, so I use this capital D. And then how we can specify, so how do we want to aggregate? There are of course many different ways, but we are interested in taking the mean. So how you basically specify the kind of aggregation way of doing the aggregation, you just specify behind here dot mean dot max dot min, so then it will basically search and aggregate based on that function that you specify here. It could be median as well, so quite handy and easy to use. So it actually uses the same functions that we have learned to use already when dealing with data. So then I just execute it, and it takes a millisecond to do it, and now we can see that how does our data look like. So indeed, now we only have daily level observations, so we have 1st of January, 2nd of January, 3rd, and so on. And then the values here, they are basically the median, not median, but the average of all these temperatures during that one day. And it was easy as this to actually do the aggregation with the date information. So yeah, so I know you are feeling pain as you did it in a quite more difficult way before, but that pain is useful because you might have situations where you are working with some other data than date, and then you cannot use this kind of approach. So it's anyway good to do. And now, as we have the daily level data, we can of course let's plot it. So let's plot the temperatures. And again, I can say that daily dot plot. So there was the plot function, and then I said that the x. So what is the x-axis values? So in this case now, it's important to understand. So the time is not a column in our data frame. What it is that it's the datetime index in our data frame. So instead of specifying with string the column name, we actually specify that it's daily dot index. So in this way we can use the index values of our data frame and use that as the x-axis values, and then the y-axis we can specify that it's the Celsius again. In Pandas it's also possible to specify already the aesthetics of how your plot will look like. First of all, there is this parameter called kind, which basically specifies that I want to make, what kind of plot do you want to make? By default, you are always making a line plot, but you can basically specify that you would do a scatter plot or bar plot or whatever. In this case, I will still keep it as line, but this is important you to know that there is this kind of way of specifying that instead of line plot, make a point plot, make a or scatter plot, make a bar plot or pie plot or whatever. So that's an easy way to do that. Then what we can do is to specify the line width. So how thick the line that we draw should be. We can specify that with this parameter called LW, so line width. And let's say that it's 0.75. So that is the width of the line. Then finally we can also specify the color of the line. So by default it is blue, but what we can do is to specify that, okay, I want to have it like red. So this is nice, and now when I do this, I end up having this kind of graph. So it's quite different looking. Well, it's basically showing the same information, same data, but when compared to the original one, when we have the hour level data, we have quite different looking graph. Yeah, there's a question.
Does it matter in which order do you type the parameters in when plotting?
No, when you're, that's a good question. So basically, if you specify, like, use the name of the parameter so that x equals to daily index, y equals to Celsius, kind equals to whatever. So whenever you are specifying specifically that this parameter equals this one, then it doesn't matter, you can put them in any order. But you don't necessarily need to actually use the name of the parameter. So I could do the same thing, I just now remove all the other parameters, but I could do the same plot without specifying these name of those parameters. So now we can see that actually the order how you should put them is actually the order of the arguments in the function here. So in this case it becomes important, but if you specify the name of the parameter, then it doesn't matter. And that is a good question, because it might kind of cause confusion at some points, but now as we can see, so now we have the same thing happening. So we have, well, here we have actually nicely, so we can see the difference between these two when we aggregated the data when compared to the original one with hourly level data. So it's not as crowded looking as before. And as well, now we have the kind of time information in a more nicely formatted. So actually we have nicely this January and the year here, and then we can see that the 2nd January of 2013 starts here, and we have these kind of monthly ticks and X labels here. Cool, so that was easy, I hope, at least for me. But yeah, one really good thing, Dave showed you earlier how to save plot by just clicking the save button in the window. But quite often, especially when you're saving or doing these kind of, let's say that you are visualizing 500 maps from Helsinki, you don't want to go and click every one of those 500 maps and save them into your computer. Instead, you want to do that automatically as well. So that is also easy to do. So we can save the figure to disk, and how we can do that is that
there's a question in the Slack about it's more about the exercise, but is there a way with the resample command to do something like sampling for quarters or for seasons?
Yeah, there are, like, the Pandas was originally developed for time series analysis and do these kind of financial stuff. So all those kind of functionalities that are related to time series, stocks, and these kind of things, they are included. So because in business, quarterly level information is important, so for sure there is way of doing that. So let's see if there. Where did I? Yeah.
The question is really about how to put different, like for example, seasons in different columns. For example, if you had the daily data,
Yeah.
if you want to, for example, get Mondays in one place and Tuesdays in one column and so on.
Ah.
So how to do that kind of thing?
Ah, okay, cool. That is a good question as well.
That's not, for example, in the material.
Yeah, it is not.
Similar to what we were
Yeah,
doing
it's not in a material, but it's really actually a good question. How you can do that? Because well, let's continue. Maybe I show the saving the figure first, and then let's go continue with that. So how to save the figure to disk? So how we can do is to use this pld.savefig. So quite intuitive. And what you need to specify here is basically the output path of your file that you want to save. So I will save it on the users/web/ and then I will give the name. So it's like pandas underscore plot 1.png. So in this case, I will save it as a PNG file, but you could change this to GBAC, PDF, all those formats that Dave showed you earlier. What is also nice in here, I don't know if you can do it with the interactive window, but to specify the resolution of the, I guess you can, but at least here it is really easy to use this parameter called dpi, so dots per inch. So what is the resolution of the image, and we can specify that, okay, let's make this kind of print quality version of the image with 300 dpi resolution. And we can basically save this. Actually now, when we have already opened the plot, it's not in the memory anymore, and basically what we need to do is to run the whole script, and then, well, it will also open these, but in addition it should have now saved our file under the, okay, there is something happening here. Well, I can go to File Explorer, and here I should have pandas plot 1, and when I double click it, well, indeed we have the plot saved into our computer as we wanted. So, but then about the question, what was that, okay, we have this datetime information in our data. So as said, let's take a look, data.head. So we have this index having information about year, day, month, and the hour. So basically what is quite cool is that when we go and say data.index, and then let's make another dot and press tabulator and see what do we have here. Actually, there is quite nice features, because the index understands that what is the year, what is the month, what is the day, what is the hour, all different kind of information, and it can be directly fetched from here. So basically we can see that, okay, the day of the week of the 1st of January 2012, it was the 6th day of that week, so I guess it was Sunday then. And in a similar manner we can of course get the year. So now we can see that it basically gives the year for each observation of that data frame. And because we can see that this is now kind of a array of those values, but if we want to say that, okay, I want to have in my data a new column called year, instead of doing these complicated string manipulations, when we have the datetime index, we can actually say that data year equals to data dot index dot year. And when doing this, we have a column where we have the year information inside. Quite handy, and you can do this for all these different kind of time intervals. You have months, days, hours, quarters of the year, business days, weekday like Monday, Tuesday, and whatever. So it's really useful. And thanks for excellent question. That was good thing to cover. We'll need to update that to the materials as well. Cool. But yeah, now we have seen how to make a kind of simple plot, one plot, but how to make this kind of plot that we saw in the beginning, where we have these kind of 4 panels with different data. So let's now see how we can actually do this kind of thing in Pandas. So as you might imagine, we kind of use the tricks that we saw now. So we can select the data again using these kind of datetime index methods. So we can basically select the data for winter months and so on. So let's do so that we basically select the data for winter 2013 and spring and summer and autumn. And basically the winter of 2013, well, actually our winter starts already year before, so typically it starts to be cold, hopefully some snow in December. So let's specify that the winter of our data is actually December 2012 up to the end of February, and then starts the spring and so on. How this really goes, it doesn't matter, but we specify it like that. So let's do that. Select data for different seasons. Cool. And I will do so that I will create a data frame called winter, and just by using the stuff that we learned already before, I say that okay, I want my winter to start from the first day of December and it lasts until the last day of February, which is 28th of February in 2013. And when executing this, we should have only those values. So indeed we can see that the last values are 2013 28th, and it starts at 1st of December 2012. So now in this way we can specify and select the data for winter. We can do the same for spring. So maybe I just copy and paste this. It's maybe a bit faster, like this. And then I specify that the spring starts at 1st of, not 1st of that, but 1st of March, and it lasts until the last day of May. and then in a similar manner I do the rest of the four seasons that we have. So the summer goes like this, summer, and it starts, hopefully, has been quite optimistic last years to have summer starting at the 1st of June. I guess this year we didn't have summer really at all, but well, we can always hope for better next year. And then the last thing is the winter. We didn't really have winter either. I hope we would have winter as well. So let's say that it starts at 1st of September and the last day is the 30th of November. And let's not call this summer, but it is fall. So now we execute all these, and basically now we should have different data for different seasons in different data frames. And what we can of course do is we can say that summer plot summer dot index, and then the other one is the Celsius. Let's just check a little bit that at least this seems to be working all right. And indeed it seems to be actually. Now, as seeing this, it was good that I checked, because it seems that we have hourly data instead of the daily data that I actually want to use. And that is because I specified it like that, but we actually aggregated the data, so I just changed that. Instead of using the hourly level, I just changed these to daily level data and execute these another time. So it's always good to regularly check your data and visualize it so that you understand what you are doing, as you just saw when I did this. Then what I want to do is to basically create a subplot. So how we can do this kind of multiple panels in Pandas, or actually in Matplotlib, is that we have this function called plt.subplot. So create a panel 2 times 2 with subplots. So how we can do this is that we have this specific function called plt.subplots, and here, as you can see, we can specify the number of rows and number of columns. So I specify that I want to have 2 rows in my figure, and then I want to have also 2 columns, so that we have this 2 times 2 panels. Then there are some other parameters that you can specify. One of the quite useful ones is to actually that you can specify what is the figure size, and I will also just to show you as well that you can do that. So you can specify that with this fig size equals to, and then inside this parentheses you said in inches what is the width and what is the height of the figure. I said that the width should be 12 inches and then the height should be 8 inches. So when I execute this, what happens is that we end up having this kind of empty figure with these different subplots and different axes here. Actually, when I see that I created these 2 different variables, so the first variable fig, it basically you don't so often actually use that variable for anything, but it is basically keeping the information for the whole figure. Whereas these axes, actually when I see and take a look what we have in the axes, is that we have these 4 different axes. They are these kind of data objects that we can use to modify separately each one of these different subplots in our figure. So basically this first one, so you can see that inside here we actually have 2 different arrays. The first one is the at row 1, so basically this one here. So this is the axis for that, and the second one is for this one, so on column 2. And here we have this plot and that plot, so the lower part of the figure. How we can manipulate and basically plot our stuff on these different figures is that we basically assign, for example, that the winter plot should go to the first axis, the spring should go to the second axis, and so on. So we basically use and take advantage of these axes from here. What in this case, I don't know if this is kind of the best way of doing things, but just to keep things fairly intuitive and easy for you to understand, I will now take those different axes and basically specify them into separate variables. So parse the axis from the X array. So as you saw, this is basically an array of axes. So let's say that I want to have the X at row 1 and column 1, so I call it x11, and then I basically take, just by specifying that I want to take the from the first array here, so from the at index 0, take the first one from here, so the first item from that array. So how we can do that is basically to specify with 2 kind of square brackets. So this specifies that take from the first array, and this second one specifies that take the first item from that list. So we can do that, and now what we can see is that indeed we only have 1 item, and it is that first one there. Then what we can do is that I want to take also the second one. So from the first array, take the second item from there. So at row 1, column 2, take those. And let's see. So now we have caps lock. So now we have the second item here, and I do the same for the last 2 ones. So I just copy and paste this and change that I want to have from row 2 the first item and the second item. So now I just change this to 1. So from row 2 take the first, from row 2 takes the second item. And let's execute these. So now we have in separate variables all these different panels, and we can start pushing data for them. So let's do it and let's see what happens. So how we can specify in Pandas that I want to add this plot into that, or this visualization into that specific plot, is that plot, create the subplots. So for example, I want to have the winter values, and I want to basically plot them in a similar manner as before. So I said that the x-axis should be winter.index and the y-axis should be a column called Celsius. Then the key here is that we have this parameter called x. So we can specify that this plot that we make here should be associated with certain axis. So basically what I want to put is that plot the winter temperatures in this one. And that axis is the first variable that we just specified here. And when we do that, so I said that x equals to x11. And what else do I want to do? I want to say that the color of my line should be blue. And what else do I want to do? I want to specify that the line width equals to 2.5. And we can start with this. And let's see when I execute this. So what happened was that indeed now it added our data into this plot. So now we have the winter data in here, and as you can imagine, we can do the same thing with all the other ones. So let's do so that we put the spring data here, then the summer data here, and the fall data here. And then we kind of might need to stop and check the exercise a bit. I just copy and paste this and change that I want to plot the spring, and I want to use the spring data frame index, the Celsius, but now I need to change that. I want to put it on the second, and let's see, does it work? Yeah, indeed it worked. Actually, I want to change the color, not blue, but have it as, for example, orange, which is the nice. Now we actually plotted one line on top of the other one, so you can in similar manner kind of plot many lines in the same figure. But now it looks like orange. And then the third one, what I want to do is to plot the summer into the third one. So I just change summer here, and then I also change the axis where I want to put it, so to the second row and the first column, and I want to use the color green because we have leaves on the summer. And then when looking, we have the green line going here, and then finally we can plot the fall, which is the last one. And let's do it like this. Fall, and change the axis. So this is the key point, that you want to change the axis where you want to add it, and let's put it like brown. And now we have all the four different data sets added into these subplots. Yeah. Mm-hmm. You mean this one? Yeah. It was because I basically what I did was that I by mistake I first didn't change the color of the orange, and basically we can do the same thing that. So it's like yeah, so it just so it's below there, so it's just you can, and that is the way how you can actually add multiple different kind of variables. We could, for example, just to demonstrate, let's also put on the fall plot not only the Celsius, but let's also put the wind speed. This might do, let's see what happens, but let's put it like red, like this, and let's see what happens. So yeah, what we have here is that we have the wind speed, and it kind of came on top of that, and this is the way how you can actually use multiple different variables and put them on top of each other. So that's also a useful thing to know, and that was the reason why we have these two here. Cool. There are, of course, we have the, now we are in this point that we did. So we have the temperatures. Actually, we should have also standardized the temperature range to be same in each one of these. That could be done by specifying this kind of y limit a parameter, and we can actually now just do that. So we just specify that the minimum temperature is 20 and the maximum temperature is not 20 but maybe 25, and the maximum is 25 as well. So this way we can actually standardize the temperature, the y-axis, to be the same in each one of these. This is also really good thing to know. And what I will do now is that I just save this and I run the whole script so that we can actually see that what happened here is that now we indeed have the same scale for all of these different plots in here. What you can see that we are now at this point not the where in place, so the plot doesn't look like this before. There are certain tricks that are useful how to manipulate the aesthetics of the plot. You can take a look of them. Don't be kind of afraid. These last bits in the materials might be quite overwhelming and maybe a bit difficult to understand. That is because we are working with date information, and there are some specific tricks that needs to be done to be able to, for example, specify that I want to have every 7th day in my plot, and that I want to have the March, April, May down here. So there are some specific tricks that are mentioned in the materials. So don't be afraid or kind of feel frustrated if you don't kind of understand them. They are not easy, even for me, to kind of remember all the details, what is going on. But yeah, you have a question.
Is there some easy how we can look at the plot multiple normal plots? Okay.
Multiple.
Are you the middle and part?
Kind of multiple. Well, I guess what you mean is that how to do, well, exactly the.
Same loop, but they can have a different scale.
Yeah, well, basically, if you don't specify the y limit, so they will have different scales. So what we needed to do, because we have like temperature data and we want to be able to compare them. So you want to have the scale to be the same, but unless you specify the y limit, so then it will be basically with different scales. Yeah, cool. Just shortly to quickly show you what you should be doing in the exercise. Please go ahead and check the last bits of the lesson materials here to see what was done for dealing with the aesthetics. But